here we're going to talk about proving similar triangles. So it's very similar. I don't want to use that word, but it's very similar to congruent triangles, where we have these similarity theorems that are just shortcuts. We don't need to show all of the sides are proportional and all of the angles are congruent. If we know that we have two angles that are congruent, if we know that we have three sides that are proportional, or if we have two sides and the included angle, that is enough to tell us that these triangles are similar. So I'm going to break that down just a little bit more. Angle-angle similarity theorem says that we have two pairs of congruent angles. Sorry, that's not true. Corresponding angles that are congruent, then the triangles are similar. So I'm just going to write an example of each of these down here. If I had angle A, it's congruent to angle A1, and angle B is congruent to angle B1, that's enough to say that these two triangles are similar to each other. Side-side-side similarity theorem says that if two triangles have three pairs of corresponding sides in equivalent ratios, then the triangles are similar. So we want to show that all of these ratios are the same. C over C1, B over B1, and A over A1. All of those need to be the same for this theorem to apply. The order doesn't matter. These could also flip-flop. You could put C1 on top, but then you'd have to put B1 and A1 on top also. Last one, side-angle side similarity theorem. Two triangles have two pairs of corresponding sides in equivalent ratios, and the corresponding included angle, which means it's sandwiched in between those two angles, those two sides. If that included angle, the pair of congruent angles are congruent, then the triangles are similar. So let's say C over C1 is the same as B over B1. C and B, the included angle there would have to be A. So A would have to equal A1. If we have all of those conditions, then we have side angle side. All right, so let's try these. We try together. Is Fox similar to mu? So looking at these side lengths, I want to think about if those ratios are all the same. If 6 over 2 equals 15 over 5 and 9 over 3. Since we divide each of those and we get 3, those are all congruent. Those are all equal, which means that the triangles are similar. So I would say yes by side-side-side similarity. All right, is C and H similar to KRH? So here we can see that we have vertical angles, and we have sides that are across from each other that might be proportional. 9 over 3 and 15 over 5. You can see actually it's the same thing. Those are both equal to 3. So we have two pairs of sides and the included angle. That is side angle side. So yes, they are similar. All right, what additional information is needed to prove that these two triangles are similar? By side angle side. So I have this side corresponding with that side corresponding with this side. So I needed the included angle. P and D would need to be congruent to each other. If you wanted to prove it by side, then QR and EF would have to share that same ratio of, really, it's 2 to 3. All right, which describes the relationship between corresponding sides of the two triangles. PQ is 4, and EF, nope, those don't correspond. PQ does not correspond with EF, so that one's out. EF is the same, EF to QR is the same as 3 to 2. And we don't have any sidelines here, and I don't really care what the sidelines are. I know the ratio is going to stay the same as whatever this ratio is. 9 over 6 is the same as 3 over 2. So, yep, that one has to be true. I'm going to go through those last two just to make sure. df to PR. Okay, so 9 over 6. Well, that should be 3 over 2, not 2 over 3. And then PQ and QR, those are both within the same triangle. Plus, I don't know what this is, so I don't know that ratio. All right, on these you try, you're going to finish the similarity statement and then write what similarity theorem you used. So I'm going to actually do this first one with us. 10 going up to 30, 12 going up to 36, 14 going up to 3. All of those are being multiplied by 3. So by side, side, side similarity, I could say that CDE, that's my longest side, that's my second longest side, so I'm going to say that is similar to KLM. So you're going to complete the similarity statement and then write what similarity theorem you used.